All right, now let's talk about an application of analytical chemistry known as titrations. Typically, we carry out acid-base reactions to the point of neutralization. Neutralization is defined as the point at which the number of moles of acid that we've added to a solution are equal to the number of moles of base present in the solution. Or we can do it in the opposite way. If we're adding base to acid, we can say the number of moles of base that we're adding are equal to the number of moles of acid that are present in the solution. So a way to express that using an equation is to say that we would add the perfect number of moles of H plus to exactly react with the number of moles of OH minus that we have and convert everything into water. Okay, this would be the point of neutralization. This reaction would be going to completion, so all we have is H2O. That would be the point of neutralization. This is called a titration. Okay, if we add just enough acid to neutralize all of the base, that is perfect point of titration. So let's do some titration examples. For example, what volume of 0.250 molar sodium hydroxide is required to react with 40 milliliters of 0.100 molar HCl if we want to completely neutralize the solution? So when we are looking for neutrality, in this case, that means that the number of moles of hydroxide that we're adding must be equal to the number of moles of protons or hydrogen plus ions that are present in that solution. So that means that the first thing we should do is to try to calculate the number of moles of H plus that we have present in that solution. And we can do that by turning this phrase into a mathematical equation. We have 40 milliliters of 0.100 molar HCl. We know that if we react HCl with sodium hydroxide, you should always, always, always write a chemical equation to describe what's going on in these situations. We are going to have water, and water, of course, is what's produced when the H plus ions interact with the OH minus ions. So we have water, and then we just have spectator ions. The sodium and the chloride are just spectators, so I'm putting them as aqueous ions. So we can translate the amount of the volume and the molarity of HCl into the number of moles of H plus that we have. Because remember, H plus is going to be produced by the HCl, right? So that really is complete. The HCl is completely dissociated into its component ions. So the number of moles of HCl is going to equal the number of moles of H plus that are present. So let's do this. I have 40 milliliters, and 40 milliliters of a 0.100 molar, so moles of HCl per liter solution. If I do that, I also need to convert the unit. I need to convert milliliters to liters because that will enable me to cancel out the milliliters and then the liters to be left with the moles. Pardon me. The moles of HCl. Looking at that equation now, I need to figure out, remember, what is it asking me? It's asking me what volume of a 0.250 molar sodium hydroxide is going to be required to react with this many moles of HCl. Looking at the balanced equation, I can see that I have a 1-to-1 ratio of NaOH to HCl. Okay, I get that from my balanced chemical equation. So now I can cancel out the moles of HCl. Now all I need to do is figure out the volume by multiplying by the reciprocal of that concentration of NaOH. So I can put the liters on the top and the 0.250 moles on the bottom. This is moles of sodium hydroxide. And that will give me the volume of sodium hydroxide in liters. So this is one long string of things, but it is successful in giving me what I want, which is 0.016 liters of the 0.250 molar NaOH solution. Okay. If you multiply that volume times that molarity, you should get the number of moles of OH minus, and of course that should be equivalent to the number of moles of H plus. So this is an example of a titration. We added just enough NaOH to the sample to get to this, this equivalence point. Okay, so what we just talked about, it would be the equivalence point. Equivalence point is synonymous with the point of neutralization, where the moles of OH minus that we added equal the moles of H plus that are present. Okay, so this is also called the equivalence point. All right, let's do another titration